Hello students. In the last two videos we showed you how to find unknown side lengths and unknown angles using trigonometry. So what we're going to do now is look at a couple of examples, a couple of applications, and we're going to start with what are called angles of elevation, excuse me, and angles of depression. So the concept's pretty simple. Angle of elevation from A to B. So here's where you are down here. You're looking at something that's above you and off, in this case, off to the right. And the angle of elevation is just this angle in here, measured from the horizontal. How high up do you have to look to see the object at B? So angle of elevation is measured from the horizontal looking up. And as you may have guessed, the angle of depression is looking from the horizontal, looking down at an object. So here you are here at point C. The object you're looking at is down at point D, and that angle in there, measured from the horizontal, is the angle of depression. So angle of elevation looking up, angle of depression looking down. Now, if you recall one of your facts about parallel lines, if you got two lines that are parallel, in this case the two horizons, that angle, the angle of depression, is the same as that angle using the old Z rule. So what we can say is, if you know the angle of elevation, you also know the angle of depression. If these are two people, if A is looking up at B at a certain angle, well, B is looking down at A at the same angle, as long as you measure the angles from the horizontal. Okay, let's go ahead. I'll do one little application, and then I want you to have a go at doing the next one. So the first step always with a word problem is read the question. If you have the question in front of you on a piece of paper, then you can underline the important information. And from that, you need to draw the mathematical diagram. Okay, a helicopter flying at a constant altitude of 91 meters. So I'll start by drawing my ground, which we always assume is horizontal. That's supposed to be horizontal, by the way. Sights the middle of a landing pad at an angle of depression of 16 degrees. So here's the helicopter. It's 91 meters above the ground. That's always measured perpendicular to the ground. Now here's the tricky bit. I'm going to go ahead and draw the rest of the triangle. And it says the angle of depression is 16 degrees. So here is a really, really common mistake. So once you know about it, hopefully you'll avoid it. A lot of students say, well, here's the triangle. I'm working out the angle of depression, and they want to write the 16 degrees in there because you're measuring from H down. What you have to remember is the angle of depression is measured from the horizontal. So the 16 degrees, in fact, is in there. So now you have two choices. You can say, well, that angle there's 90 degrees. 90 take 16 is 74. So you could write 74 degrees up there. Or you could sort of say, well, there's the Z rule. The angle of depression is the same as the angle of elevation. So the 16 degrees is the angle here. So either way, it doesn't matter which way you do it, you'll end up with the same correct final answer. And the question is, how far in meters must the helicopter travel to be directly over the landing spot? So what they're talking about is this distance just here. So the helicopter is going to fly horizontally until it's above that, which is the same as this length down here. So I'm going to call that D. Okay, there's our mathematical diagram. Let's go ahead and work out the different sides. So we can say there's the angle. Well, first off, the angle opposite, the side opposite the right angle is the hypotenuse. The side opposite the known angle is the opposite, and the side next to the known angle is the adjacent. So which sides are we going to use here? Well, we know the opposite side is 91 degrees. We're trying to find the adjacent side, and which is letter D, opposite over adjacent. We're going to use the tangent ratio. So tan 16 degrees equals, oops, I should put the whole rule in first. Let me undo all that. So tan of theta, I'll just write the rule first, is opposite over adjacent. Now we'll substitute everything we know. So tan of 16 degrees equals 91 over d. Now we need to solve this equation for d. Now the small problem here is our d is in the denominator of the fraction, but we did learn in a previous video there's a quick way to solve this equation, which is to do the old swaparoo, or what one of my friends calls is the sneaky swap. We showed you that algebraically you can just swap the d and the tan 16. So we'll do that like so. And now it's just a matter of typing that into the calculator. And I think we'll do it to the nearest meter. You don't measure, distances that you fly to centimeters, you measure them in meters. So 91 over tan 16. Let's clear what we had from the previous calculation. And I need I need a fraction. 91 over tan 16. Check what I've typed matches. It does. And that's going to be 317 meters, rounded off to the nearest meter. So summarizing that, probably the trickiest bit here is getting the diagram right. So get your mathematical diagram, probably double check that everything you've written there matches what's in the question, and then it's just a matter of using the trigonometry that you've previously learned. Okay, we'd like you to have a go at this question, please. So read carefully, draw the diagram. Once you finish, start the video again to check your answer. Okay, let's see how you went. A swimmer, 0.32 kilometers from the base of a cliff, looks up and waves to her friend who is at the top of the 110-meter cliff. Find the angle of elevation from the swimmer to the top of the cliff and give the answer to the nearest degree. Well, the first thing we have to do, even before we start the trigonometry, is to turn all of these into the same units. So 0.32 of a kilometer, multiply by 1,000, and that gives us 320 meters. Okay, I'm going to draw my cliff just there. I'm going to draw the ocean just there. So there's my right angle triangle. We'll assume the cliff is 90 degrees to the ocean. There's the swimmer down there. There's her friend up there. And what do we know? We know that the swimmer is 320 meters from the base of the cliff. So I'll put B there for the base of the cliff. And we know that the cliff is 110 meters high. And we're trying to find the angle of elevation from the swimmer to her friend. Okay, so carefully reading the question, that's the mathematical diagram. Okay, let's find out which trig ratio we're going to need for this. So the side opposite the right angle is the hypotenuse. The side opposite the known angle is the opposite. The side next to the known angle is the adjacent. And we know the opposite side, we know the adjacent side. Opposite over adjacent, that's the tangent ratio. So we write down the formula for tangent is opposite over adjacent. Okay, let's write in everything that we know. Well, the angle is what we're trying to find, so that stays as theta. And opposite's 110, adjacent is 320. So to find the angle, we have to take the inverse of tangent. So inverse of tangent. And again, just keep that as a fraction. No need to change it to a decimal or no need to simplify it. And now it's just a matter of typing that carefully into our calculator. So shift tan fraction 110 over 320. And we're going to do this to the nearest degree. So we 18.97. So therefore, the angle of elevation is 19 degrees. So angles of elevation and angles of depression are pretty straightforward. The main thing you have to be careful of is angles of depression. If you're told the angle of depression is 16 degrees, you must write it measured from the horizontal and not measured from the vertical. So that's easily the most common mistake that students make with these sorts of questions. Okay, in the next video, we'll show you another interesting application of trigonometry, which is bearings.